how do we configure our OT framework? How do we configure our OT network, right? Because as OT guys, right, we don't have a lot of control over how the business IT guys do their thing, right? We have to live in our own little sphere and world, right? So now we're here in the OT network, and we want to get stuff up into the cloud because, as I said before, right, this guy is a cloud device, right? I don't want this guy to know how to get into my OT network, right? That's a bad idea. So there's many consumers of OT information in our organization, even outside of our organization, right? That we want to give pieces of information to. And we want to get this from browsers. I'm sitting in a hotel room. I want to wake up in the morning and check the status of my plant, or I want to look at my phone, or all these reasons for wanting to do this. And even external organizations. I want to send some supplier an inventory level that says, hey, we're, our hopper full of isopropyl alcohol is getting low or something like that, right? But the OT network should absolutely be isolated from these consumers. We shouldn't be giving them the ability to go into the OT framework to get any of this information, right? So we want data transmission to the cloud. We want that secured at rest and secure in motion, just like we did in the OT process land, right? We don't want anything to be able to come in there and just intercept a packet and make changes to it and be man-in-the-middle attacks or anything like this, right? And communication to the cloud should be originated from the OT network. The cloud should not have the ability to reach into our OT environment and start to do anything, right? Anything that I send up there, I should be in control of. Anything in the cloud should not be able to ask for something that I didn't agree to give them. Okay? And there's a lot of stuff that can happen up in the cloud, and I want to be able to bring that sometimes back into my OT framework, like analytics or, different AI stuff or all kinds of things that can happen up there. But it should all follow the same path, right? And like you look at this and like people say, I can't send data to the cloud, right? It's too risky. Well, what's the real risk of putting data up in the cloud? The cloud is actually a pretty secure place. You ever been to a data center that runs the cloud, right? They're like fortresses, But the cloud is a pretty secure place. And what's really the issue is, if you think about it, it's you don't want something being able to spoof your OT environment and change the data before it gets up to the cloud and give the cloud something erroneous, something that you didn't originate from the OT framework. And now people consuming this are using false information because somebody in the middle is changing it before it gets there. So we're back to our multicolored network again, and we'll talk about this from the process control LAN upwards now versus we talked about this from the, and so we still got the same thing. The orange network is the process control network, the red is the DMZ, the green is the business network, and the purple is the cloud. So we need to be able to, have a DMZ on top of our OT framework, and this should be isolated from the business network. We should have 2 firewalls, right? And you shouldn't be able to just punch through both firewalls from the OT environment. You shouldn't be able to, I should have to do something to get in. Firewall 1, the lower firewall, should allow me into the DMZ, but it doesn't allow me out of the DMZ. Right? Something's got to change everything so I can send it out from the DMZ. So we have a component in here called Insight Secure Link. And the cloud is known as Insight. And Insight Secure Link allows us to daisy chain this intrusion protection and go through multiple customers got 6 firewalls between the OT network and the cloud. Right? If the cloud had to make a direct connection to the OT network, he'd have to violate all 6 firewalls. They're not willing to do that. They put those 6 firewalls in for a reason. And so we have to be able to respect the multi-levels of intrusion protection before we get data out of the OT environment up into the cloud. There's other components we can put in here, but mostly we're going to talk about the thing that gets up to the cloud. And so when we, in the business and network, you still want all the same IT security policies that you've, heard about. We have no ability to change that, right? We're here down in the little OT land, and, we're not going to go to our IT guys and tell them to change their entire networking strategy and environment, because they're just going to laugh at us. So we need to be able to live with what we're given and support that whole infrastructure. So this is where you want things like your Pi historian, or even maybe an AVEVA historian if you want to. You don't want the OT guys, the IT environment, to be able to go into the OT environment and do stuff. You want them isolated. So, everybody up there can do all the things they want. They're not going to impact anything on the OT environment, right? And you need to respect all your intrusion protection that's been put into place. So as we send data up into the cloud, right, we want to secure that data transmission to the cloud via this component we call Insight Secure Link. And we'll talk about that in just a second. But all transmission should be encrypted, should be certificate-based and encrypted with TLS 1.2, right? When we send data up to the cloud, the first thing we normalize, we split the data into two packages. One is a descriptive package, which describes what it is we're sending. Tag name, where it is, what its purpose is, maybe some engineering units around it, all the metadata around what it is this value is. And the other is a package of the values. Both packages are attached to a GUID. Everybody know what a GUID is, right? It's a global unique identifier, a number that can never be repeated. And all the numbers are normalized to a value between 0 and 1. So if you could break the certificate, which you can't, if you could inspect the package, which you can't, if you could look at the data, all you get is nonsense, because every value looks the same. So you don't know what you're looking at, what it is, and you wouldn't know what to change it to if you wanted to. So the transmission of that is initiated from the control domain, and the cloud is able to provide a bunch of services, right, that we may want to expose to our OT environment. And we should be able to do that through this same maze of intrusion. Right? So for instance, we have the Insight Historian can do time series data, right? It can do OEE for machine performance. It's got a news feed for unsupervised analytic. This is a thing as we throw data up into the cloud. The cloud's got lots of horsepower, right? So we just grind through your data all day long and look for patterns and relationships. We call this unsupervised machine learning. There's about and it even does things like, it does individual tag values, looks for like change in entropy or change in frequency or level changes or other things, but it also does multi-tag systems. Like it'll figure out that these 4 tags are related to each other. Historically, they've always tracked each other, and then they don't. And it'll tell you that now they don't, right? And this is, now, what it tells you may be completely nonsensical because it's not smart enough to be able to differentiate it, but it will sit there and say, hey, I found these things. What do you think? And it does learn based on your responses, right? So if you say, yeah, that was really cool, you can give it a thumbs up, or give it a thumbs down and say, no, that one wasn't very good. But if you got a temperature and a pressure in a vessel, they should track. And if they don't, something's wrong, right? And you want the system to tell you, right? It does condition-based analytics up there. We have guided analytics for asset-specific artificial intelligence. Like you can tell something, hey, you're a pump, you're a compressor, you're a heat exchanger, right? And it knows how to interpret that information based on knowledge of the asset that it is, right? And then there's obviously advanced analytics for multivariate AI, where you have massive, neural network kind of stuff. But it can generate dashboards and even process graphics, right? But it can securely distribute this information to cloud consumers. And we can expose it to other applications with OData and RESTful APIs. So your phone apps or your browser applications or everything, they're not trying to penetrate back into our OT framework. They're just going to the cloud, living in the cloud, happy in the cloud, right? Doing all that stuff, right? And we're not threatened by those guys because they have no knowledge or capability to penetrate back through all our intrusion protection. So Insight Secure Link is this software component that you download off the cloud, and it provides eventually a single outbound port with 443 up to the cloud, right? It allows no inbound communication, so no one can originate a connection through it. It'll only allow you to push data out. But once it establishes that connection, it is a bidirectional connection. But it will only allow you to connect to the cloud services. So once you establish the connection, you can consume stuff back down through it. You just can't set that connection up. And it allows you to daisy chain through all your intrusion protection. They can be daisy chained together. So I can go punch into the DMZ, go to the DMZ, punch into the business network, punch into another DMZ on top of the business network. Whatever I have to do, I can weave through all the maze of intrusion protection that I have in place, right? Many vendors, cloud solutions, expect you to say, here, I'm on the OT framework and I'm going to connect to the cloud. Well, wait a minute. I got 6 firewalls in the way, right? How do I do that without something like this? And so this thing is also whitelist maintained from the AVEVA cloud. So the AVEVA cloud will tell this guy what it can connect to, and it will reject an attempt to connect to anything else. So if I try to go to Google or I try to go to Yahoo or any of these other things, it says, no, not from the OT network. You're not doing that, right? You're not going to read your email on the OT network. You're not going to do these things on the OT network, right? That's not what the OT network is for, right? You want to do that stuff, get off the OT network. And it'll block websites. It'll basically say, hey, if you want to go to apple.com, no, sorry, you can't do that from here. And it's easy to change ports and locations, right? So you can have it weave through all your intrusion protection so that you're not sending one pathway through all your firewalls to get up to the cloud. And you tell it to forward to. So now, how does all this stuff work together? Right? So basically, you have some sensor read some device, in this case, we're looking at a pressure, right? Here's the pressure. It's 35.4. We'll read it from some device, some PLC. That goes through a COM server and into our object server that is in, and that becomes identified as to what that is now. That's now tank A pressure, right? We now know what it is. We know what the value is. That communication to that, from that IO server to the object server was all certificate-based. It was encrypted, certificate-based, right? No one could intercept it or interpret it or look at it and do anything that wasn't a part of the team, right? Hadn't been invited to the club. Doesn't have the keys. We then send that up into the OT historian. The OT historian gets that value, saves it, distributes it out to anybody on the OT network that wants to look at it, right? And then it splits it into 2 pieces. It creates a packet of metadata describing what this is, attaches it to a GUID. And then it'll send that up through the firewall, into all the intrusion protection, through the web proxies, through everything that's in place on our whole stack of stuff that we want to use to protect ourselves, and gets it up in the cloud, stores it in the cloud in an encrypted form, right? As the metadata, tank A pressure, attached to a GUID. And then we take the value, reduce it to a number between 0 and 1. Now it's 0.354 instead of 35.4. It's attached to a GUID as well. And that gets routed up through all the intrusion protection that we have in place to get that up into the cloud. And that's stored in a separate location in the cloud environment. So now, if I was to put this together nefariously, I have to break into 2 different stores, right, that have this information. And I go to look at this with a browser or a phone or anything else or REST API, and it puts it all neatly back together again and tells me, here, you wanted to see tank A pressure, it's 35.4, right? So this is how we transmit data up into the cloud. It preserves all the intrusion protection that we have in place. and encrypts it and secures the transmission at rest and in motion all the way down from the I/O server all the way up to the cloud through all the things that we have in place to protect it, right? And there's nobody up here in the cloud that can go backwards through this environment back into our OT framework. So then the other thing is that there's all this neat stuff that the cloud can do with the data. So we could generate some kind of metric, but we can consume that back down via the same path because we've already established the path. The OT environment established the path through all this intrusion protection. And it's, once established, it is bidirectional, but it can't be established by anybody other than someone on the OT environment. And then we can consume that into our user interface and give the operator or the enhanced information about what's happening with this process based on the power of the cloud being able to provide that. So that's how AVEVA sends data up into the cloud. It's a very effective mechanism, and I guess we're open for questions.